All right, good morning, guys. Morning, morning. How's everyone doing? Morning, Liberty. All right, we got one person. Morning, Rachel. Perfect. Okay. So got two. Looks like maybe one more. Maybe Hunter's here. Cole's here. All right. Good to see you, Cole. Awesome, awesome, awesome. So Cole's here. I wonder if Hunter is too. We get all four. I don't know if we've had all four. Maybe once in this stream. So just so you guys know, come on, Cole. Let's be real here. In terms of attendance, I think Hunter's got it you beat by a little bit, but I guess I can't make that mistake anymore. Gotta stop thinking like that. If you guys want to get out your homework from Monday, I know it's not due till Friday, but if we want to talk about it, we can look at it. Cole says I'm here every time. I believe you, Cole. I just don't always know because I don't always get feedback from you, so I'm never positive. But I'm sure you're lurking in the shadows, watching this stream every time. So Unit 8 FRQ B is where we'll start. And I think I'll just probably go over the answers. And then you guys can let me know if you want to go over anything specifically. Cole, I felt like you a little bit. I couldn't sleep at all last night. Like I'm talking, maybe I got 3 hours of sleep. That was it. And it wasn't out of like choice. Like I went to bed. It just I couldn't fall asleep. So I know you feel that pain sometimes, so figured I'd share with you. All right, so this will be where we're at, guys. This problem here. That's the worst. Also, I had the same thing happen, but I'm here and I cleaned my room to start a day, so I'm not gonna lie. See, Cole, that's the thing. Even though sleep deprivation is happening, we're still getting things done, pushing through it. That's what we need to do, Cole. Push through this. Clean my room to start my. What a start to the day, cleaning a room. I probably should have done that. My room's atrocious. And go out of the chat, guys, if you guys are ready. If you have your work open for Unit 8 FRQB, if you guys have that work open, go out in the chat and let me know so I can get started. I'll read off the answers. Getting into everyone's favorite unit. All right, Rachel, Liberty ready? Cole's ready? All right. Cool. All right, so guys, for 1A, your answer should have been the natural log of the absolute value of k. Again, for 1A, it should have been the natural log of the absolute value of k. For letter B, this one had quite a bit of parts. You had to find the perimeter. So basically, you had to do side 1 plus side k, plus the base, and then plus the curve, or the arc length of the curve. So you had 4 different pieces you needed. So you could have had any sort of variation of this, but you had to have these 4 parts. So you had to have 1 plus 1 over k, plus the quantity k minus 1, plus the integral from 1 to k of the square root of 1 plus the quantity negative 1 divided by x squared dx. So again, you should add 1 plus 1 over k plus the quantity k minus 1 plus the integral from 1 to k of the square root of 1 plus negative 1 over x squared. Okay, part C, you end up getting pi. Your answer is pi. Okay, was there any of those that you guys would like to talk about or go over? Or get justification on, anything like that? We'll give it a second, go ahead and type that in the chat. Rachel, can you go over C? Yep, no problem. All Liberty agrees. Okay, so let's go over C. I'm assuming you guys got B then, right? I know it was kind of hard to read off that answer, but were we okay with B? Let me switch over to my camera here. B was good. Okay, cool. B, the big thing was just remembering the arc length formula. Once you get the arc length formula, though, it wasn't too bad of a problem. All the other different lengths, I don't think were too bad to find. So, okay, so C. This is the key. So C says it says region R is rotated about the x-axis to form a solid. As k increases without bound, find the volume of the solid, or show that the volume is infinite. So some of your big hints, obviously, are just the idea of this forming a solid. That's always a really big hint on what to do. If you guys remember from last year, you learned something called the disk method. I don't know exactly, all you guys got through last year, but you should have learned at some point about the disk method. And it was just a way to solve problems where you have a region rotated about an axis. Specifically, the disk method was useful for the x-axis. Okay, so we got to start with that. And I'm pretty sure you probably called it the disk method. Maybe not. You hear about the washer method as well. So the disk method is saying this. We want to find a volume of a region being rotated that's forming a solid. You want to take the volume. That's going to be equal to pi times the integral from a to b, okay, whatever your bounds are, of f of x squared dx. So you guys can see to find a volume, right, we're taking an integral of an area, right, an integral of an area. This area is the area of a disk, okay? So what we're basically thinking of is pi r squared. So this is representing your r squared, right, r squared. So that's where the disk method comes from, just as a quick refresher. Volume equals pi r squared, because that's what area is equal to. Okay, so this is going to be like kind of our little cookie cutter outline of what we're using. Now we got to fill in some pieces. So volume's going to be equal to, pi is just always there. That's not a variable or anything, so that's going to stay there, right? Then we got to think of our bounds. Okay, well it says in the question, it says we want to show as k increases without bound. Okay, well we know that in the original question it starts at 1, this area. Starts at 1, but then they're saying that k is just going forever, okay, because we want to find this answer as k keeps going and going and going and going. So we want to take then oops, sorry, not k, 1 to infinity. That's our bound, because our k, if we look back at the picture, that k, we're assuming just going to keep going unbounded. And we represent that idea as infinity. And then f of x, they give us what the function was. The function meaning what the function of that curve is 1 over x. So we have volume equals pi times the integral 1 to infinity of 1 over x squared. All right, now we want to actually solve this, okay, and get an actual value. If you guys remember, this is called an improper integral. So whenever we have an integral that's approaching infinity, we call that improper. So we had a tool we used to do that. So what we basically want to do is, to find that volume, is we want to take the limit. We can use k in this case. You might want to use t. Depends on whatever, as long as you understand the context. So I'm going to use k just because that's the variable they're using. So we want to find the limit as k approaches infinity of pi times the integral from 1. Instead of infinity, we're replacing it with k. So the integral from 1 to k of 1 over x squared dx. Right, because 1 over x, the whole quantity squared, is the same thing as 1 over x squared. Okay, and then continue with that, I get the limit as k approaches infinity of pi times, in this case, negative 1 over x from 1 to k, or at the endpoints 1 and k. So this integral, right, you can change this to just x to the negative 2, and then use the reverse power rule to get to negative 1 over x. I'm thinking we're okay with that. Okay, and then just manipulating this, I'm going to get the volume equals the limit as k goes to infinity of pi times negative 1 over k minus pi times negative 1. If I were to actually evaluate this limit, I'm going to see, ideally, right, I'd probably do it like that, right, because I'm evaluating the limit of the whole thing. This limit, as k gets larger, this value is going to approach 0. So 0 times pi is 0, minus a negative pi is the same thing as plus pi. So that's where we get our final answer of pi. All right, any questions on that? You guys good? Makes sense? Any step I need to review? Makes sense? Oh, wow. You guys are like copying and pasting each other's sentences. All right. Sounds good. So for the next 45 minutes, I want you guys to start on FRQ Part A. So Unit 8 FRQ Part A. Number 1 shouldn't take too much time. So there's going to be 2 questions. Number 1 shouldn't take too much time. 2 is a little bit longer, not too much longer. Before you get started, let me just kind of warn you. Remember what happens when you have a area you're trying to find, and it's bounded by 2 separate functions. So you guys are going to see that in portion 2 of the assignment. We can deal with it when we get there, but I just want to remind you guys that we're subtracting the area from the taller one minus the upper bound and the lower bound. Okay, so just remember that. But you guys can go ahead and get started. Number 1. I think number 1 you can use your calculator. Yeah, so you guys can have your calculator out for number 1. And I will be here. Any questions as you guys go, let me know. Just to reiterate, guys, for this problem, you want to use your calculator whenever you can. So I'm saying that just because I don't want anyone to go down like a rabbit hole. If there's ever an integral you need to evaluate, just plug it into your calculator. That's going to save you a ton of time for this problem. Yes, Cole, you're supposed to be in radians. Good call. Real quick, too, guys. Hopefully everyone's listening right now. I made an update to the calendar. You do not need to do 2D in tonight's homework. So College Board Unit 10 FRQ Part A, there's Part 1 and Part 2. You don't need to do Part 2D. So it's going to be Lagrange error bound. That's not going to be tested on the AP test, so I'm not going to worry about it. So just skip that part. It'll save you a little bit of time. Okay, and that's in the calendar, so you can double check that. But I wanted to make it very clear, so I made it bold and very big letters. So just so you guys know. Carry on. Thank you, Rachel. Appreciate it. I was thinking to myself, how rude are these guys? Just gonna hear me sneeze my brains out and not say bless you? Also, I apologize if you hear me chewing. As always, I didn't eat breakfast, so I'm eating it now. But you should be happy, at least I'm eating it. It's a big step in the right direction for me. Why don't we curse when we don't like when they sneeze? Huh. I think rudeness does play a factor in that. General rule of thumb I live by, Cole, is just don't curse anyone. But I know some people have different viewpoints on that. So maybe yeah, I think just you just always want to bless rather than curse would be my answer to you, Cole. Great question though. I mean that's why you come to Mr. Harris lectures, right? You want to get answers to those types of questions. So hopefully that helped. It seems like a power move though. Depends on where you're going with it. I mean, theoretical situation. You know, like Mr. Harris, he sneezes. You say, curse you, and I'm like, excuse me? I don't know how much power move that's going to be, because I'm just going to not like you, and I'll probably just give you a bad grade. So I don't know if that's necessarily the best idea. Maybe if like you have like a little brother who's like just annoying you, and he sneezes and he's always excited because big brother, big sister is gonna say bless you, and you say curse you, and they're like, oh, I mean that could be a little bit of a power move. So like, hey, I own this place. This is my territory. So I think maybe in the context it could be a power move. I don't hate the idea, Cole. I think it's a conversation starter. Just might be rude in certain scenarios. So just be careful. How we doing? You guys need help with anything? We good? For part C, can I just do the integral from 0 to 45 of the absolute value of v of t? You got it. That's exactly what you do, Liberty. Gets a little bit tricky putting it in the calculator, but if you guys actually Actually, this is something good because I'm sure you probably already know this, but let me talk about this real quick. So, if you guys are putting this in your calculator, see if I might already have it in there. That'd be awesome if I do. Oh, I do. Perfect. Okay. So let me just double check my camera to see if you can see it. Yeah. Okay. You guys can see it. So start by just putting your function in y1, and you needed to do that for part 1a anyways. So you should have already had this in your calculator. So you can see this gives me just the function they gave us, and it's really big, long, not a parentheses, really annoying to put in, right? So just so you guys know, if you're using your calculator to put in the integral, right, you can go to math, and then, oops, hold on. Let me go back. Math, and then go down to integral, so 9. Again, this only applies to 3 of you, not to say names, Cole. It's going to be a little bit different, but. So we're going to go our integral from 0, in this case, to 45. And if I wanted to use the absolute value, I can go to math again and go to 1. So math number 1 and go absolute value. I think you're fine with all that. But then this part, instead of having to type out the whole function, I don't know how you guys do it, but another way you can do it if you're wondering is if you press alpha and then your graph, and then you can scroll over. So you can see they give you like all these things. If you scroll over all the way to the end where it says y var, it gives you all the different slots of your graph. So you can just press, for mine, my function was input into y1, so I can just put enter on y1, and it'll just look like this. So in your calculator, put 0 to 45, the absolute value of y1. It's with respect to x. Okay, and then you press enter, it goes through its thing, and you get the answer. And I actually just gave you the answer for 1C, but that's fine. Casio problems. It was a choice, Cole. I don't feel bad for you. And yeah, for whatever reason, this takes really long to calculate, so it makes me scared a little bit. You think, oh, maybe my answer's wrong, but I promise you what you have is right. So yeah, that's a little helpful hint for you guys. So you get your final answer of 250.099. 0.099. It's a lifestyle. You're right, Cole. It takes a special kind of person to have a Casio, Cole. Smartest people use a Casio. Look it up. It's a fact. All right, I'll look it up. Let's see what we get here. I'm getting some interesting feedback on that, Google. Maybe you could like send me a link on that, Cole, because so far I have a wide variety of things popping up. Maybe I have to be more specific. So, I'm sorry there, Cole. I think I can confirm that is not the case. I'm not finding a source that is saying definitively Casio users are smarter. There hasn't been a test on that. I'd be interested to see the test, but... we see it was a personal study done in the Himalayas with people with the highest IQ, and I observed. All right. I didn't see that coming, Cole. Didn't see it coming at all. The Himalayas. First of all, I'm very curious how that trip was. Did you climb any mountains? I mean, that's just stuff that I can't believe after teaching you for almost a year. You've never come out and told me about your Himalayan trip. A little shocked by that. Interesting to find the people with the highest IQ. I'm assuming you got the brightest of the bright, the Elon Musks of the world. And it's interesting that they are very adamant and care enough about this topic to come out to your personal study. I mean, it really is. What a story that is, Cole. I think you can apply for scholarships with that story. Pretty cool, and I would love to see your results sometime. Yeah, Liberty, I can go over the answers. Sorry, I was in a very important discussion with Cole. Really a one-sided discussion, mostly me talking of the Himalayans and highest IQ people being there. Crazy distracted, my bad. So, number one, I'm going to read off the answers, and then you guys can let me know if you want to go over anything. So, for 1A, the first time that Gwen changes direction, also known as T sub 1, is 19.416. For the average velocity, you had to use the formula for an average value. That formula is 1 over b minus a times the integral from a to b of f of x. In this case, right, it's not f of x, it's v of t. It's not a to b, it's 0 to t sub 1. So your fraction out front is 1 over t sub 1 minus 0. Throw that into your calculator, you get 7.264 feet per second. So two answers for 1A, 19.416 and 7.264 feet per second. For 1B, you're just putting in your calculator without an absolute value. So it's just the integral 0 to 45 of the function v of t, and you get 116.538 feet. Again, 116.538 feet. For 1C, you get 250.099, like I put in my calculator, so you guys already saw that earlier. And for 1D, you get negative 4.844 feet per second. Again, negative 4.844 feet per second. And it says, to explain the meaning of in the context of the problem, you should add something along these lines. Acceleration is the rate of change of velocity. So the integral from 15 to 30 of a of t is the net change in velocity from t equals 15 seconds to t equals 30 seconds. The whole premise of 1D was using the second part of the fundamental theorem of calculus. All right, so those were your answers. Let me know if you guys need to go over anything. Yeah, no problem, Liberty. Yes, Mount Everest. I'm a secret and mysterious man, so I have my connections. Yeah, Cole, I know how you operate. I know you probably know a lot of monks out there. They probably get you the lowdown of the situation. I understand. I get it. Would you guys ever climb Mount Everest? Do you think that's ever anything you would do? Would you have to get paid to do it? What do you think? I don't think I ever would. People die. So that's a little bit of a, scares me off a little bit. Also, I just have no interest in climbing. I don't really see, I don't see the thrill in that. Other people might. I don't really see the point. There's pictures. I can just look at the picture. It'd be a cool story, but pretty dangerous. You have to have the right group of people to do. Also, I'm definitely not in shape to do that. You have to be in freak shape to climb Mount Everest. So you'd have to work out for like years to get into the correct shape to get your lungs capable of even handling a Mount Everest expedition. And plus, like Cole said, I don't have the connections Cole does. I don't know the monks out there. Cole does, but I don't. So maybe he can hook me up and reach out to some of his buddies, and maybe they could help me. But if I did it on my own, no way. I'm toast. Cole, I would again. Yeah, for the second time. So I'm curious, Cole, did you guys do this study on top of Mount Everest? Is that where the study was conducted? All the highest IQ individuals climbed to the top and then did the study? Because that'd be interesting to me. I would be willing to. I'm not super. Yeah, I agree, Liberty. I don't think it's something like I would like set my life to. Quit my job, go off, go to the Himalayas, and just like climb out. Like I don't think that it would ever get to the point where that was what I wanted to dedicate my time to. If some situation arose where maybe I got paid to do it, or I don't know, like just some crazy situation arose where I guess I would be willing to. It's a cool test of your resolve, your individual resolve. I think that's a pretty cool like test, because there's not too many things harder than that. Wow, Cole. Cool. I'd like to like think, yeah, he went to like some website and copy and paste this, but I know this is coming right out of your brain, which is hilarious to me. Death is a good companion in life, you know? You never truly live if there's no risk. Think about it. We're all living on a rock hurtling in space, so who cares? Interesting take on it, Cole. I think not to such an extreme extent. I think that's somewhat how I live my life. You gotta take risks in life. I mean, if you really think about it, you're taking risks every day. Every single day you're taking risks. Not as much in quarantine, there's not as many risks you can take, but anything can happen. You can't live in fear. Life is about the small things. In the grand scheme of things, we're all going to die. However, the experiences and personal relations we have make it worth living. Man, Cole, nothing like some deep hump day conversations at 9:45 in the morning. This is what I'm talking about. This is the philosophy. This is some motivational stuff here, Cole. You can take this on tour. Go to the Himalayas. Preach this word. I like that. If you live sheltered and doing stuff you're not happy doing, what kind of life is that? You only get one of them, right? Well, I guess it depends on what you believe, but generally we believe you get one of them. So you gotta experience. You gotta have relationships. You gotta take Calculus BC with Mr. Harris. This is my plug. Just wanted to, I have my stream now. I might as well plug myself. I'll go down as a Z at least, so it's all good. I'll have made it already. Zen is already within my reach. Cole, you're on another spiritual level I can't compare to. You'll never make it past. Okay, wait. Am I missing something? What is this Z and Q thing? Should I know what this means? Or am I being stupid? Or is this like am I too old to understand what these mean? Lies into C. I'm getting it from this one. I Man, I'm really confused. To the lighthouse? What's a lighthouse? I need answers, guys. It's gonna stress me out. I'm gonna have to Google it. Don't make me Google it. Never make it past Q. Until the lighthouse was oddly capitalized, so I'm curious with that, Liberty. To the lighthouse. Maybe it was an accidental, or a lighthouse an actual place. You know what? I already value the good things about life. In my very little experience of life, I have no what is worth disliking or stressing over. Hey, that's half the battle, Cole. Half the battle is just figuring out what you want to put your time towards in your life. So you're already if you already got that, that's a pretty good skill to have. To the lighthouses. Oh, so I did. That was Mr. Harris made good connections with the capitalization. Liberty, that was not a mistake. That is a title. Proper noun. I think. I teach math, but I think that's what we call a proper noun. And it's a book we read. Okay. So I'm guessing, just spitball. Oh, they're just going to tell me. I'm not going to spitball. There's a man who believes intelligence is measured in letters. And the smarter you are, the farther down the alphabet you are. That's fantastic. Okay, so do they each stand for something? Does every letter stand for a different type of intelligence, or is it just like a scale of 1 to 10, but it's a scale of A to Z? Cole has a hot take. That man was a fool and worthless as a family man, until the end, which he finally achieved. He finally reached R at the end of the book, and that's a fact. Okay, see, I mean, R is pretty far down the line, so it sounds like it's all right in my head. Tough take though, Cole. Pretty brutal on this guy. He might have been a jerk, so I'm not going to defend him, but oh wow. Each generation only has maybe one Z. Okay, so Z is almost an unattainable feat. So Cole, he says me. Liberty says no, intelligence is completely linear. Interesting. So, is this book intelligence? What is it based off of? Are there because I know like in psychology, there's I don't remember 7 intelligences or something like that. Some smart guy figured that out. In the book, are they basing it off all those different types of intelligence, or is it just like one specific intelligence? Or does his scale A to Z have its already built-in formula for types of intelligences that maybe are accomplished by tasks? I'm curious now. I need more details, guys. You can't get me going like this. It's Virginia Woolf. He is just a character. It wasn't a major part of the book, just one character's philosophical take on the world. You just kind of know for yourself which letter you are. Oh, I got you. So you can self-appoint letters. Reaching the final state of being completely at ease in most intellectual discussions. Not an easy thing to do, but smart recognizes smart. Just like real recognizes real, Cole. Smart recognizes smart. Cole, I don't know about that. I disagree. As sad as it is, I don't think there's not enough things in this world to have an entire generation of you being the one person that like succeeds the most at that. I bet you could find something though where like you could say like, yes, I'm the best at this. Like for example, I could say that some stupid task of I can break the most peanuts in a minute and say that's I'm Z at peanut breaking, right? But if someone else could come along pretty easily, be like, oh, I just never thought to do it, and then destroy my high score. So I really don't think we're all Z's. If I'm gonna be honest, I would say I'm not a Z at anything. But I think in general intelligence, I would say this class as a whole, including Hunter. Hope Hunter's doing well. I would say we're all pretty high up on that the intelligence scale. I don't think we have any A's in here. Name one thing that makes me not a Z and I'll accept it. Cole, can you dunk a basketball? And rationalize it, of course. No, because I don't know. It's too subjective. Because there's no actual scale to measure this. This is all basically what you think. So, the way I see it, Cole, is if you think you're a Z, then you're a Z. That's how we gotta look at it. If you think it, then that's the case. I'm willing to grant you Z-hood. He said yes, of course. Can you play 17 different instruments with ease? Rachel says no, Cole is not a Z. Rachel, what would you label Cole? I think Liberty labeled him an R. Oh no, Q. Liberty said he's lucky to get to Q. Cole could not be our Z. Like it's speaking for your generation. Oh, does Mrs. Graves? She doesn't believe she's. Oh, that's a good question to ask her though. Guys, I gotta be honest. I don't think any of us are Z's. Let's be real here. From what I understand, if that's a one in a generation person, there's someone our age that's gotta speak, guys. I think we just gotta lick our wounds and come back. How about Hunter? Can we label Hunter as a Z? I'm willing to go on a limb and say Hunter's a Z. He's not here, so he doesn't know, but I'm gonna label him one. In fact, for the fourth quarter, guys, I'm changing our grading system. Calc BC will be graded entirely on A through Z, so I'll be grading each of your intellects. And it'll be just my own there's going to be no like rubric. I'm just going to wing it. Liberty. No. I didn't say that. I never said I didn't believe in them. I believe in my students. I have full faith. Cole, this is my motivation to you. Go out there and prove them wrong. Go out there and show the world you're a Z. Cool. Hopefully that pumps you up a little bit. You can just clip that and play it on repeat and like go do some Z stuff and then that'll motivate you. Liberty, I'm kind of confused about B. Well, on the intellect scale, Liberty, B would probably be like really high up, so not very intelligent. Maybe that'll clear it up for you. I'm just kidding. I know what you mean. All right, so B. 2B. I'm going to go over that real quick because we don't have much time. So 2B says, uh-oh, did I do something stupid? Hold on. No. Let me get back into the assignment. Cole, I think that's natural, though. I think it's natural to zoom through the letters, and then eventually you're going to hit a point where you're going to stop, which is why I'd say intellect isn't linear growth. I would say it's more of maybe almost more of a logarithmic growth. I think you grow rapidly, and then you kind of taper off. Okay, so it says, hold on. We have about 3 minutes. Let me fly through this. Okay, so first things first, it says to find the volume of a solid generated when r is revolved about the x-axis. So this is exactly like the problem we reviewed. So the problem from 8. The problem from 8 FRQ B. So like at the beginning of class, what we reviewed. So we're going to use the disk method. The only difference with this one is that when we do our volume, we're going to still have our pi. You guys should have already found in the first part of the question that they intersect at 0 and they intersect at x equals 0.833606 or some version of that, right? And so the only difference with finding volumes of these solids as opposed to finding volumes of where it's just the x-axis connected to the curve, the difference is that now we want to take the difference between the upper curve and lower curve. So that's the big idea of the volumes that's contained within two different functions. So we take our first function or our upper function, which in this case you guys can see is our tangent inverse or inverse tangent function, squared, and then minus the lower function, which is x squared squared. X squared squared. So this is going to be what you put in your calculator, Liberty. Very similar idea, just the big difference here is just that minus. Cole, there's no plateau for a life form such as myself. Is that what you're referring to yourself now? A life form? I think that boosts you 1. So if you think you're at a Q, then you're 1 above after saying life. After referring to yourself as a life form, that's a big step in intellect. No plateau. I like to think there's no plateau, Cole. Just like a logarithmic function, Cole, it's going to grow. It's going to keep growing. It's just going to grow very, very minuscule. You're going to get to 60 and you're just going to kind of stay the same, not get that much more intelligent. Maybe even get dumber. I don't know. All right, BC, I didn't realize it's 10 o'clock. Friday, guys, I'll be here. Friday isn't mandatory. I mean, none of them are mandatory, really, but I appreciate you guys being here. Friday morning, I'll go over anything you guys have over the week, Calc BC. So if you guys want to come in, we can have a nice casual conversation about an intellect again, whatever you want to do, but I'll be here bored probably, so I'd be happy if you guys came in and asked some questions and we can go over some problems and I'll give you the answers and stuff. So Calc BC, make sure you guys submit your homework over College Board. So everything's assigned to you. Just submit it on College Board. Let me switch my camera so I can be a little more personal. So on College Board is where you'll submit your work for that, guys. Specifically, I want your work for the homeworks because we almost got through everything. It looks like we almost got through everything on this assignment, but we can go over that Friday if you guys have extra questions on it. Just try to get everything submitted to College Board. All right, Cole, that sounds good. My FRQ is the graph of x squared. You're gonna be at z in no time if that's the case. Good morning, Haber, Jasmine, Katie. How are you guys? Calc AB, you guys missed a very fun conversation BC had today. There you go, Rachel. Rachel. Ow, ow. That's what I'm talking about. I'm like a hype man today. Yeah, Liberty. That's me cheering on BC for completing their assignments. All you AB kids who are like, what is he on? See you, Cole. Cole, you're cracking me up today. Let me tell you, man. Oh, man. Good morning, Peyton. Oh, Peyton, you should not be confused. This is a very interesting conversation to be having. So anyone who didn't come in earlier had no clue what was going on. Our conversation in BC was about intellect on a scale of A to Z. Now, I guess this isn't a book they're reading. I don't know if you guys can scroll through the chat, but if I scroll through the chat, it's called something about the lighthouse, I think it's called. I've never heard of it, but they just kind of started talking about it, To the Lighthouse. And I guess there's a character who labels themselves, considers intellect on a scale of A to Z. And a Z intellect is like one in a generation. So there's only one person in that generation that is a Z level intellect. And so Cole kept saying to himself, yeah, Haber, you got it. Cole kept saying to us, hey, I'm a Z, guys. And Liberty and Rachel weren't having it. They were like, no way, you're a Z. If you're a Z, then I'm ZZZ, you know? And they got, this heated conversation. Cole was very adamant he's a Z. So he's saying he's a one in a generation brain. And I didn't deny. I mean, I'll accept it. If he wants to be a Z, he can be a Z. Oh, Cole's still here. I thought Cole left. I thought I was talking behind his back. So it's pretty interesting conversation. Peyton, what letter am I? See, Peyton, the thing with A to Z, the thing with To the Lighthouse, is you got to rate yourself. You label your own letter. So what letter you think you are, that's the letter you're at. And then you can strive to get to the further levels. But at the end of the day, it's more of an interpersonal, intrapersonal, actually, I think would be the word. I teach math. I think it's intrapersonal. But you gotta, it's like an internal battle that you have to have with yourself. Yes, exactly, Payne. You identify as a Y. Wow, that's impressive, number one. Very impressive. But yeah, okay, you can identify as a letter. Cole's not a Z. He'll never break through Q. Now, that's a bold statement, Liberty. I don't know if I can get on board with that. I have faith he can break a Q. I'm going to say that, Cole. For sure, you can break Q. Brandon, I'm a straight up A. No, Brandon, when I think of A, I think of an infant. I think you start your life at A, right? So I'm got to be, honestly, I think from the ages of 0 to 3, you're flying through the alphabet. I think you're going A, B, C, D. You're learning all this stuff. You're learning how to walk. You're learning how to go to the bathroom. You're learning how to talk. You got all this crazy intellect, right? So the way I'm seeing is you're moving up the scale pretty quick. Hey, Avery, that was the same argument Liberty made, I think. Peyton almost as a G's. All right, I like the confidence, though. Cole, love it. Yeah, I told those guys, here, let's bring it into math. This conversation To the Lighthouse intellects A to Z. The way I see it is it's like a logarithmic curve. I think you start your life just flying through those letters. Like, I think all of us are probably right around the middle. Your math teacher, I'm going to be honest, I'm probably a little higher than you guys, just experience. I'm not saying, I think I just had a little more experience than you, so I'm probably a little higher on the alphabet. But I think you guys grew really quickly, and we're probably still in a pretty quick growth. But eventually in your life, I think it plateaus a little bit. What letter do I think I am? I think I would be like at about a Q or an R, somewhere over there. That's where I feel like I would be at. I would venture to say everyone in this chat right now is above average. I know for a fact. Yeah, I would say at least higher than. Let me do an alphabet in my head. I would say higher than N. I think everyone's higher than N. There's my take. I think I'm the highest. So whatever you guys say, I'm not gonna allow it unless you're lower than me. So if I'm gonna stick with I think R. So you guys have to be behind me. So I'll allow Q, but no one's at an R. Sorry. That's just the rules. That's the calculus rules. I make it. I'm the boss. That's how it is. Brandon, it doesn't spread like that. You can't just spread it like that. All right. Sorry, guys. I enjoyed that conversation, but let me focus back up. So, Unit 3 FRQ. Let's start there. So everyone open up your Unit 3 FRQ Part A. I will go over one question from that assignment, if you guys have one. One question from the Unit 3 FRQ assignment. So go ahead in the chat. Hopefully, I didn't even start the class off. I hope you guys are all having a good day. Hope everyone's doing good. If anyone cares, I ate breakfast this morning, so that was good. Fayan said B. Okay, so Fayan wants to go over 1B. I wasn't sure, Payne, at first when you said that. I thought you were referring to someone's intellect as a B, which made me laugh, but now I realize you probably want to go over 1B. Okay. Oh, let me switch this page. All right, I'm going to go to my notebook now. All right, so again, guys, this is going to be Unit 3. This was assigned to your homework. Like I said, come to my office hour or email me if you guys have questions. I don't want to take all of class going over some of this stuff. Ideally, write homework still. Like, that's stuff I'm taking for a grade, so I want to see your input. But Friday, we'll have a review session. Anytime during the week, just let me know if you guys want to go over this stuff. But I figured we can start class like we do normally, and I'll go over a part of one of them. So Peyton said she wanted to go over Unit 3 FRQ Part A. She wanted to go over Part B. Okay, so one thing we have to do is first, and you actually found this in Part A. Now, I know already not too many people tried this assignment. All right, so here, actually, just because of that fact, let me just start here. I know a lot of people haven't started this assignment. I get it. It's okay. It's not due till Friday, but it's always nice, too, in case you have questions, so you don't have to panic at the last minute and be like, Mr. Harris, answer my email. And I'm like, guys, it's 10:30 at night. I can't do that. So to start the problem, okay, they give you this table. They give you what g of x equals to. So g of x is equal to 5x squared minus x. So we have a composite function here. Whenever you guys see a composite function, you have to be thinking chain rule, chain rule, chain rule. So first thing has to go through your head. Eventually, if they give you a composite function, their expectation is you're going to have to use chain rule. That's the whole point. That's the little trick they'd use. All right, so this is a composite function. Just off your top of your head, you're like, okay, chain rule is probably going to be in play. And in fact, it is, because Part B asks for the second derivative. It's asking for the second derivative of f. Okay, well, first let's find the first derivative of f. And I'm going to actually do that by finding the first derivative of g. Can we do D too? Yeah, D won't be too bad. We can do D. Okay, so G prime, let's start there. And the reason why I'm doing this, because if I'm looking for the second derivative of f, and I'm given the second derivative of g in Part B, I need to get to a general statement for those that connect those two. So if I'm finding the first derivative, I'm using chain rule. Chain rule says to find the overall derivative, or the general derivative. So the general derivative f of x squared minus x is f prime of x squared minus x, and then multiplied by the derivative of the inner function. The derivative of x squared minus x is 2x minus 1. So you needed that for Part A. That actually helps you guys a ton for Part A. So I kind of already included Part A in this. If you guys are keeping score there. But like I said, we want to know really what the second derivative, because we have information on the second derivative. We know that g double prime of 0 is equal to -1. So let's first find g double prime of x. This one's a little more complicated, right? Because I'm taking the derivative of g prime, which is a product. When you guys take the derivative of a product of functions, what do you use? Mr. Harris, you use product rule. Very good, Brandon DiGidio. Great answer. We're going to use product rule. So I'm going to take the derivative of the first function, which is again, chain rule. So it's a derivative overall of the function, which is f double prime of x squared minus x, times the derivative of the inner function. So that's the hardest part of this problem, is like you have to do that chain rule idea again. So that's the derivative of, I'll just put it in red. That's the derivative of the red. There we go. Let's try to organize our work. Okay, and that's going to be multiplied by the second function. So the derivative of the first function, which is all in that red box, times the second, which is 2x minus 1, plus, shoot, my bad, people. Spacing was not a good call here. That's okay. I'm going to go in the next line below. I know it's not looking good. Okay, so then the product rule says you want to plus the first function times the derivative of 2x minus 1, which is just, let me do it here, sorry, 2. There you go. So the derivatives are in blue of the second, the derivatives in red of the first. So you get this big long thing. Sorry, I should have wrote it on one line, but I didn't realize how long it was going to be. This is what you're left with. Now all we got to do then is to find g double prime of 0. So I want to find g double prime of 0. You don't have to use this step. I like to do it just because, like, in my personal opinion, I think it really helps organize my work. So I'm going to replace all my x's with 0 and write what I have left. So, like, if you plug in 0 for x, I'm going to get f double prime of 0. 2 times 0 is 0, minus 1 is negative 1. Same thing, negative 1. F prime is 0, and 2. Okay, and what we're ultimately looking for, like what our question is asking for, is f double prime. That's what the question asks for. So we want to isolate that. I can replace g double prime of 0. We know g double prime of 0 is equal to negative 1. So I can replace that with negative 1. Negative 1 times negative 1 is 1. So I just have f double prime of 0. F prime of 0 I can find by looking at the table. So you guys were given a table in this problem. F prime of 0 is going to be 2. So you just look at the table, you find where x is 0, look at where f double prime row is, and then you can match it up and you can see it's a 2. And then just do algebra, right? Pretty easy from here, and you get negative 5 is equal to f double prime of 0. Yeah, Brandon, I'm really good at that. I can read minds. All right, so that's part B. Part D. I know it's kind of weird going out of context, especially this is the first time you're looking at this problem. But at the very least, you guys can have this work, and then you can go over it when you do the assignment. Okay, so part D says let h be a function with derivative given by h prime of x is equal to 4e cosine x. It says at what value of x in the interval negative 3 to 0 does the instantaneous rate of change of h equal the average rate of change of f? All right. Well, guess what? We already have one piece of information that's important to us. We're already given the instantaneous rate of change of h. They gave that to us. That's what a derivative is. It's an instantaneous rate of change. So bam, set. Next thing we want to know is the average rate of change of f. Okay, to find the average rate of change of f, so AROC of f, we got to take our interval and find the slope. So f of 0 minus f of negative 3 divided by 0 minus negative 3. That's how you find an average rate of change, right? You just find the slope over an interval. All right, and we can look at the table to get these values. So you guys go back up to the table in the problem. It'll give you what f of 0 is and f of negative 3. You know, solve that, and bam, you get 3. So essentially what this question's asking is, when does 4e cosine x equal 3? That's what the question wants to know. And guess what? We can use our calculator. So we want to find when that's true. I need you guys to graph 3. I need you to graph 4e to the cosine x and find where they intersect on the interval negative 3 to 0. Find where they intersect on the interval negative 3 to 0. And when you do that, you get x is approximately negative 1.863. So that was kind of like fast-paced version. Let me ask, is everyone okay with the calculator part? I know I skip that a lot of times. Are you guys understanding of how we can get that answer? Because at the end of the day, you need to get there, right? On the AP test, I don't want you guys getting through the whole thing and being like, oh, wait, how did Mr. Harris actually get the answer? What does it mean to use a calculator? So if you need me to go over that real quick, I can show you what I'm doing. But if you guys are good, then we can move on. So just let me know in the chat. Okay, so Brandon said not really. All right, thank you, Brandon. That's what I'm looking for. All right, so let me show you, Brandon, what's happening here. So what you want to do is first, let me get my calculator out. All right, so go to your graph. So not just for Brandon, for everyone, okay? Because I'm sure a lot of people have these questions if it's not just one person. Okay, so go to your y equals, and I want you guys to type in the first left side, which is 4 e to the cosine of x. So type that into y1. I think you should be able to see. I know there's a glare, I apologize, but hopefully you can tell what I'm doing. And then the second line, all you're going to do is just put 3. So these are two different functions. Okay, well, the point of this question is we want to find when are these equal. Here, actually, maybe I just do this. Let me see if that gets rid of the glare a little bit. That's better. Okay, so you guys are going to graph that. So just press graph. Okay, it's going to give you this big, long, winding thing. We only care from negative 3 to 0. So what I'm going to do actually is make my window. I'm just going to do from negative 4 to 1. And then I'm going to graph that. So you're just going to go to window. You don't have to do this part, but for me, it's just going to make it easier for me to see like what's going on in that very small window. Okay, and I can see this red line. So everyone look at that red line. My solution to an equation is whenever they're equal. So whenever this blue line is equal to 3, that's what I'm looking for. Okay, this blue line equals 3 when they intersect. So I can just do, I can go to graph, and then go to second, calculate, and you want to go to where 5, it says intersect. So second, calculate 5. It's going to ask you for the first curve. So it's going to be in the blue, you press enter. It's going to say second curve, you should highlight the red now. You press enter. It's going to give you a guess, you don't care. Press enter one more time, and then bam. You can see down here, that's your answer. That x value is the point where they intersect. So let me see if I put that up like that. Can you read it? Probably not. Yeah, not bad. Whoa. Nah, it's not going to zoom in. That's fine. You get the gist. And there's your answer. All right, does that help, Brandon? Let me know. Sometimes I take stuff for granted. I need you guys to speak up if there's a question you have. Okay, cool. Thank you for asking though, because that's the stuff that's like super important. Because if I just keep going through the stuff assuming you know what's going on, then I'm not doing my job, am I? All right, guys. I want you guys to open up your FRQ Part B. So Unit 3, FRQ Part B. Hope you guys are loving this stuff. I know we love FRQs, so this is like, I know nothing makes you guys happier than free response questions, so this is really good stuff here. And the best part is our AP test is going to be all FRQ. Hopefully, though, I think by test time, you guys are going to be really comfortable with these. You're gonna have done enough of them where when you see the one on the test, you're not going to be like, what the heck is going on? think you'll be very prepared. So I feel good about that. Okay. So Unit 3, progress check, FRQ Part B. So I'm going to actually switch screens here so you guys can see what's going on. This is the question we're on. So there's actually not too much going on here. They give us an equation. And I'm just going to write that down. You know, that's what I like to do. I always like to write down information that I'm given in these FRQs. I recommend you do the same. For me, it just helps me formulate stuff, and it helps me keep things organized, and I like that a lot. So that's why I do it. You don't have to, but it's useful to me. So that's the curve we're given. We're given this equation. Right off the bat, like let me talk to you about like how my brain sees it when I look at this problem. So right off the bat, I'm seeing something interesting. Okay, I'm seeing that there's a y and an x on the same side. A lot of times when these problems are given like g of x equals 3x squared plus 5, or you know, f of x equals g of 2x plus 2, whatever it may be. But they're separated. You usually have a y on one side and x is on the other, or another type of function on the other. This one's kind of weird. This is like a complicated function of y's and x's that aren't simplified. So y isn't isolated. All right, whenever we have problems like this is a hint to implicit differentiation. That's what this is telling you, basically. It's saying like, hey, guess what, buddy? You got to use implicit differentiation. All right, that's kind of your hint right off the bat. So going into 1A, it asks me to show that a derivative is equal to whatever. I don't really care what the right side is. I'm just going to go through a normal derivative and then check my work to see if it matches, right? So essentially, all I'm finding is what's the derivative of y. Okay, well, I can't just take the derivative of both sides because I don't have y isolated, right? So I have to use implicit differentiation. Okay, now the first thing, implicit differentiation. We're taking each separate derivative. All of these derivatives are going to be with respect to x. So I'm taking the derivative of a y with respect to x. You guys got to remember that y is a function of x. Okay, this is just a reminder of implicit differentiation. We've done this a lot, but you got to remember that y is a function of x. So let me go back to my camera here. Okay, looking at this problem, I want to first take this derivative, so just focusing solely on this. All right, so I can see that it's going to have to be some sort of chain rule. So I'm going to take the 3 out front, because I got to take the derivative of the whole thing, which is going to be 3 2y plus 1 squared, times the derivative of the inside function. Well, the derivative of 2y plus 1 with respect to x is 2y prime. That's the biggest mistake people make right there. So you take the overall derivative. I have to use power rule. So I take the 3 out front, 2y plus 1. The inside stays the same always. Subtract 1 from the exponent. You multiply that by 2y prime because the derivative of 2y plus 1 is 2y prime. All right, and that's the first derivative. Derivative of 24x is just 24. So, or negative 24x is negative 24. Because remember, it's derivative with respect to x. So when you take the derivative, that term has an x in it. So we just do it like a normal derivative. And then derivative of negative 3 is 0. Okay, now I want to solve for y prime. That y prime is the same thing as dy dx, right? So to do that, I'm going to add 24 to both sides. And then I'm going to divide by 3 times 2y plus 1 squared. So I'm left with 2y prime equals 24 divided by 3 times 2y plus 1 squared. And then finally, to get y prime by itself, I'm going to divide by 2. So I'm going to get 24 divided by 3 times 2y plus 1 squared times 2. All right, and then 3 times 2 is 6. 24 divided by 6 is equal to 4 divided by 2y plus 1 squared. And what do you know? Guess what, guys? In the original question, that's what it wanted us to find it was equal to. So we did. We did find that y prime is in fact equal to 4 divided by the quantity 2y plus 1 squared. We rock. All right, any questions on that part? I'm assuming your silence is either I'm on a big lag or you're good. So I think I'm not on the craziest lag, so you should probably already have processed it. So I will move on. That is 1A. Implicit differentiation was the focus of 1A. Okay, so you can see this problem included implicit differentiation. Now let's see what else it includes. Interesting. Write an equation for the line tangent to the curve. Okay. At the point -1, -2. So that means that we need to first, to find an equation of a tangent line, we first need to find the slope of a tangent line. Can't have an equation of a line without a slope. So I'm just going to make a little note to myself. What is the slope of the tangent line? Well, guys, I've said that millions of times this year. Nah, I haven't said it millions of times. I'm exaggerating. But I've said it quite a bit. Right? If you're finding the slope of a tangent line, that's a derivative. So guess what? I already know what the derivative is. I already know what y prime equals. Y prime equals 4 over 2y plus 1 squared. Now what we want to do is figure out what the slope is at the point -1, -2. Okay, so not so bad. All I got to do is I got to plug in my values. Well, there's no x's, so it makes our lives a little bit easier. I can't, -1's not going to be plugged in anywhere because there's no x's anywhere. So I just got to plug in -2 for y. All right, so I get 4 divided by 2 times -2, which is -4, plus 1, which is -3, squared is 9. So y prime equals 4/9. Just going to highlight that because I know I'm going to need it. Okay, and that's great. We have the slope of the tangent line, but the question asks for the equation of the tangent line. So I need to use point slope form. So I have y minus a -2 is equal to the slope 4/9 times x minus -1. You don't need to simplify, but if you were to simplify, you would get y equals 2 plus 4/9. Sorry, that should be -2 plus 4/9 times x plus 1. And that's the answer. That's all you got to do for part B. I want you guys to notice this kind of process, right? We started with implicit differentiation to get a derivative. After getting a derivative, we found an equation of a tangent line. This is a common theme in these free response questions. This is a very popular type of free response question. All right, finding a derivative and understanding how that relates to the equation for a tangent line. The derivative gives you the slope of the tangent line. To find the equation, we go back to algebra, and we just use point slope form with our new slope. Very common to have both of those included into one free response question. So make sure you guys have very strong understanding of that. Okay, part C. I'm going to flip my page here. Hopefully you guys got all the... If you need me to go back, just tell me. So just in the chat, type real quick, Mr. Harris. I didn't copy all that. I know I'm going fast, but I don't want to go too fast where everyone's kind of lost. So I need you guys to let me know if there's an issue. Okay, so 1C. 1C, pretty short question. It just says to evaluate the second derivative at -1, -2. Oh boy. Okay, so what we need to do is this. If we want to find the second derivative, first of all, I'm going to do this again. Y prime is equal to 4 divided by the quantity of 2y plus 1 squared. Okay, you don't need to write that again. I'm just writing it again so I have it. I need to find the second derivative, so I'm looking for y double prime. All right, you guys want to take a derivative of a quotient. What should we use? Quotient rule. Very good, Jasmine. Thanks for the answer. Quotient rule. We want to use quotient rule to solve this derivative. So, our favorite saying, we take low times the derivative of high minus high times the derivative of low all over low squared. All right, and I'm sorry again, I misjudged my room, so it's not the most neatly written. The first part's not bad, right? Low is just the denominator, so 2y plus 1 squared, times the derivative of 4 is 0. That's great, because that's going to get rid of this whole first term. Minus high, which is just 4, times the derivative of low. Remember, guys, when we're taking this derivative, you have to remember this is still with respect to x. We still are treating y as a function of x. Meaning that the derivative of 2y plus 1 squared, I have to use chain rule. So I use 2 times 2y plus 1 to the first, right? That's where I get 2 times 2y plus 1 to the first, times the derivative of the inside. The derivative of 2y plus 1 is 2y prime. Again, very, very common mistake people make right there. If you're going to get this problem wrong, it's because of that. Whenever you're using implicit differentiation, always treat y as a function of x. Okay, now the question asked at the point -1, -2, which, by the way, is the same point as part B, right? So all I'm going to do is I'm going to plug in all these values. So I'm going to take the double prime of 2 times -2 plus 1 squared times 0. I didn't even need to do all that. I was just being stupid. I could have just completely ignored that. So this turns into 0, right? So if you want to write your answer cleaner, just ignore that entire first part. Minus 4 times 2 times 2 times -2 plus 1 times 2, and then y prime we found in the last problem. If you guys remember before, we found y prime at -1, -2 was 4/9. So it's going to be 2 times 4/9, all divided by 2 times -2 plus 1 to the 4th. So, Mr. Harris, why are you doing that? Why are you not simplifying? So the reason I'm subbing it in is just so you understand where I'm getting values from, number one. More importantly, though, the reason I'm doing this is because this is your answer. Why do anything in your calculator? Why do any more work where you can make mistakes? Just keep it like this. I would probably have just turned this into 0, just because that's annoying, but that's my fault. But my point is that, guys, you wanna keep this written as is. No simplifying, no room for error. As long as there's no longer values of y, no more variables, no more functions, then you're good. If anyone was curious, though, if anyone wanted to keep going and check their work, if they did it on their own or something, or did it a different way and they want to see if they were right, it should simplify, or it does simplify to 64 over 243. All right, that was part C. This is something we got tested on, right? I gave you guys tests on this. This is stuff you've seen before. So hopefully this is coming back to you a little bit. I'm looking at the chat, so if at any point you guys need me to go over something or review things, let me know. I'm looking there, so I'm going to keep going if I don't see anything. Part D. So part D says that we have a point 160 on the curve. We want to find the value of the inverse of y, or the derivative of the inverse of y at x equals 0, is essentially what that question is saying. Y to the negative first prime of 0. So that's what we're looking for. Okay. So if you guys remember, we have a formula for this. Okay, that formula says that y, the inverse of y, the inverse derivative of y of 0 is going to be equal to 1 divided by y prime of y inverse of 0. So that's a formula we have for finding derivatives of inverses. 1 over y prime of y inverse of 0. In your notes, you guys probably saw a lot of f of x and g of x, just depending on how it was written. Okay, you can see it either way. They might say, like in the question, g of x is an inverse of f. So it's the same thing, just different notation. So a couple things. I'm going to bullet point them. You don't need to necessarily do this, and I'm just doing this to formulate my work so you guys can see where my brain's at. I know that 16, 0 is on the curve. So what does that tell me about the inverse curve, right? Because at the end of the day, we're finding the derivative of the inverse. Well, if I know 160 is on the curve, then I know 0, 16 is on the inverse curve. So if 160 is on the function or the curve, maybe function would be better. Maybe I'll put function. 160 is on the function, so 0, 16 is on the inverse, right? That's how you find inverses. You switch x and y. So that's going to be really useful for me because now you can see x is 0. So I have then y inverse prime of 0 is equal to 1 over y prime, okay, y inverse of 0. So when x is 0, what is the y value on the inverse? Well, I just found that. On the inverse, when x is 0, my y is 1/6. So y inverse of 0 is 1/6. So I'm left with that equation. Time for another little bullet point here. I need to find what y prime of 1/6 is to get my answer. Okay, well I know what y prime is. I've written it like a million times now. It's 4 divided by 2 times y. Okay, what's my y value when x is 1/6? It's 0. So instead of 2 times y, I'm going to put 2 times 0 plus 1 squared. Again, how did I get that? When x, because this is y prime of x, when x is 1/6, I already wrote this up here, it was given to you in the problem, y is 0. So my derivative is equal to 4 divided by 2 times 0 plus 1 squared. Pretty easy for us to do. That's equal to 4. So my final answer is going to be y inverse prime of 0 is equal to 1 over 4. Nice, pretty simple answer, 1/4. All right, and that's FRQ Part B, question number 1. So guys, let me know how that is for you. Any questions you have, I'll wait a second. Just give me a thumbs up in chat if you're good to move on. If you need help with anything, let me know. The patented Emma, thumbs up. Thank you. Oh, hey, I'm seeing some new people. Thank you guys for the feedback. All right, cool. Cool. Looks like we are okay. All right, so I got about 15 more minutes. I don't want to rush through, but I think we can get a pretty good chunk of question 2 done. If not, I mean, we should be able to get all of it done, but I'm going to go through this pretty quickly. So go ahead and go to question 2. All right, and we are going to do 2A. Make sure you guys can see my notebook. All right, so let's get started then. Question 2 gives you a table. Says the table above, let me just switch to the camera here. It says the table above gives values of differential function f and its derivative for selected values of x. Okay, so you got this table. This is going to be useful to us, not huge right now. Let's just dive into the actual question. Let g be the function defined by g of x is equal to my composite function f of x squared divided by e to the x. We want to find g prime of -1. Okay, same old story, guys. Like I always say, if I need to find g prime of -1, I need to first find what g prime of x is. Okay, so to find g prime of x, I'm finding a derivative of a quotient. We should be using quotient rule. Low d high minus high d low over low squared. So low d high. Remember, it's a composite function, so it's the overall derivative, which is f prime of x squared, times the derivative of the inside, which is 2x, minus high. The derivative of the low, or the denominator, is just e to the x, right? Derivative of e to the x is e to the x. All divided by e to the x squared. Okay, now I want to find what g prime of -1 is. So that's going to be equal to e to the -1st times f prime of x squared, or -1 squared, is going to be 1. So f prime of 1. 2 times -1 is -2, minus f of +1 times e to the -1st, all divided by e to the -1st squared. So I'm just plugging in -1 for x, right? If I want to find, so my answer isn't done. I need to keep going. And I need to go until there's no function values, there's no variables. So I only have one more step to do. I can keep e to the -1st. I have to evaluate f prime of 1. All you guys got to do, you go to here real quick, is find f prime of 1. So my derivative at x equals 1 is 4/3. Then I have times -2 minus f of 1. I go to f of x. I go to 1. That's 2/3. And don't go any farther than that. Sorry, no, I'm not on my... That's what your final answer is going to be. Don't go any farther than that. So the second you replace all function values, all variables, once those are replaced, don't keep going. Don't put that in your calculator. It's too much work. It's not worth your time. You don't even need to rearrange these negative exponents. They're not going to take off points for that. If you wanted to, if you didn't feel comfortable, you can go ahead and put 1 over e, but it's not necessary. If you're one of those people who really wants to just check your work and just to be certain, you end up getting, if you were to simplify it, you get negative 10e divided by 3 is what that simplifies out to. Okay. So flipping the page here, let's do 2b. Sorry, just trying to get this organized right. Okay. So 2b says let h be a function defined by h of x equals f of negative 2x. Look at this. Same situation. Like I said, guys, we want to find the derivative of h at x equals 1. Well, we can't do that until we find the derivative of h. So we have to find what h prime of x is. Hopefully you're thinking to yourselves, okay, I'm taking a derivative of a composite function, right? This is a composite function. It's a function f with the function f of negative 2x inside. So this is a complicated composite function. It's like a composite with enough composite, right? This is a composite function, and this is a composite function. I know, minds are being blown right now, all right? But that's okay, it doesn't change how we do things. Okay, so the first step, if we're taking a derivative of a big composite function, is to take the derivative of the entire function, which is just f prime of f of negative 2x. All right, that part's pretty easy. This is using chain rule, the derivative of the overall function, multiplied by the derivative of the inside. This is where it gets a little bit more challenging because you have to use another chain rule. The derivative of the inside is the overall derivative of f of negative 2x, which is f prime of negative 2x, times the derivative of the inside. So times negative 2. Because the derivative of negative 2x is negative 2. I know that's a lot to take in right there. Chain rule within a chain rule. So your first part is just taking the overall derivative, that's not too bad, times the inner derivative, which is f prime of negative 2x times negative 2. All right, I need to find h prime of 1. So I'm just going to replace all of my x's with a 1. Pretty easily done there. So f prime of f of negative 2 times f prime of negative 2 times negative 2. Okay, and then like I said, to get your final answer, you're going to use your table. So at f of negative 2, my y value is negative 3. F prime of negative 2 should be 1/3. And then times negative 2. Again, I got those function values from the table. I'm sorry, I circled this, but is that my final answer? I'm not going to wait in the chat, but hopefully you're thinking to yourself, no, Mr. Harris, that's not your final answer, and you're correct. I can't have this as my final answer. I can't have f prime of negative 3 in my final answer. So I actually have to take this one step further and actually evaluate f prime of negative 3, which ends up being negative 1. So your real final answer is in the blue there. H prime 1 is equal to negative 1 times 1/3 times negative 2, which equals 2/3. Okay. Uh-oh. Okay, part C. Oh man, guys, if you didn't notice, these are all the same questions. So part C, actually, I'll tell you what. I'll let you guys try to solve part C. So you have the rest of the class. So you got about 7 minutes to solve part C. So I'll write what you're given. K of x is equal to f of x times. I like to write arc sine as sine inverse of -1, or just sine. Like I prefer to write it like that. But if you guys want to write arc sine, by all means, go ahead. So at the very least, I would like to see if you guys can get like that, the very first step, just the derivative of k. So I'll give you like 4 minutes to do that, and then I'll go through the rest of the question. So in about 4 minutes, I'll write down the steps, so you guys still have it. But all right, so you guys can see I wrote the beginning part here. All right, so check your work. If you're finding that first derivative, you take product rule. So derivative of f times sine inverse of x over 2 plus the second, or plus the first function f of x times the derivative of the second. So derivatives of inverses. If you guys remember, derivative of inverse sine, you don't have to memorize these. You guys will have your notes, and you'll have a formula sheet for the test. So you'll be able to see this, but what you get is you get positive 1 divided by the square root of 1 minus whatever your value, your function is, your function value, your x value, which in this case is x over 2, squared. So I wrote that really small. Let me see if you can see it. Not horrible. And then times, because it's a chain rule. You're taking the derivative, but you have to multiply by the derivative of the inside function. The derivative of x over 2 is 1/2. So that should be your general derivative right there. Okay, and then what I want to do is I want to evaluate this at -1. So I'm going to find f prime of -1 times the inverse sine of -1/2 plus f of -1 times 1 over the square root of 1 minus -1/2 squared times 1/2. So all I did in that step was I just replaced every x value with -1. Okay, and then your final step is you just want to look at your table. So look at the table to find f prime of -1. It's 6/5. Sine inverse of -1/2 stays the same. F of -1 is -2. And then this entire last term can stay the same as well. You don't need to simplify. No need to make a mistake. That's going to be your final answer. Don't simplify, just keep it like that. All right, so AB, that's going to be your class. Just remember, guys, I know there's a ton. I'm going over a ton of stuff. So if there's at any point you guys really need help or you're struggling, please email me. Please go to one of my office hours, anything. I have no problem with that. I'll go over problems with you. I'll take my time with it. This is just kind of my way to get the information out to you. You'll have a video so you can recap the video, try to go through stuff. I want to get this out first and get as much information as I can to you. If you personally are like, Mr. Harris, this is killing me. I have no clue what's going on. You're going way too fast. I get it. Come see me. Send me a message somehow so I can help you out. Okay, I hope you guys all have a fantastic day. You're basically done for the week if you choose to be. I will be here from 1 to 2 today on stream. I will also be available on Friday. So from 10 to 11 on Friday, guys, I'm all yours. I'll go over anything throughout the week. Any question you have throughout the week, I will go over. Make sure you guys are turning in your College Board assignments to College Board. I will be posting grades for the spring break stuff pretty soon here. So I'm giving some people a little extra time to finish it up, and then I will be grading all those. Okay, I think that's everything I want to say. You too, Aber. Thank you. Have a great day, guys. See you, Brandon. See you, Stacklin. Have a good day. Have a good day, Baron. Thank you. Algebra. How's it hanging? How's everyone doing? Good morning, good morning. See you, Peyton. Guess what we're doing today, Algebra? We need a little boost. A little change of pace. So we're gonna start our day off with a little hangman. But I'm gonna need someone to give me a suggestion. I need something in the chat. Give me a topic. Yeah, sure, Jaden. We can go over some homework. Fine. Blake, we say happy birthday to Sarah. Is it Digidio's birthday? If it is, happy birthday, Digidio. I will not be singing, but I'll just pretend I did. Oh, it's not your birthday, Digidio? Or no, you don't want people singing? Jane says animal. Animal, okay. Animal, okay. Alright, I got one. Alright, guys. It is her birthday. I don't know if it is or not. Happy birthday, though, if it is, Sarah. I never know with Michael and Blake. Those two are up to no good sometimes. You guys might be lying to me. Jaden says A. There's no A, Jaden. Oh, I realized like your hangman's in the middle of a sunspot. That's okay. Not Tiger, Michael. Good guess. Carol Baskin. The answer is not Carol Baskin. Jaden says E. There you go. There is an E. Carol Baskin. What does she say? Something about how are all my cool cats and kittens? What is it? Oh, it's so dumb. What's up, my cool cats and kittens? That's what she says. Oh boy. Oops. Come on, people. What letters we got? Kind of in the way. Jaden, thank you for participating. But there is no S. G. There you go, Sierra. That's huge. It's a huge hint. Sarah, how could it be zebra? There's a G. Good guess, though, I guess. If you didn't know there was a G, that's a good guess. Digidio with the win. Gecko. Digidio, welcome to the winner's board on your birthday. Joining the winner's circle. Well done, Sarah. In honor of your victory, I'm going to put Happy Birthday, Sarah on the whiteboard. There you go, Sarah, in honor of your birthday. Gecko. I like geckos. Big fan. Yeah, Michael, probably keep those to yourself. He is, anything ever said in that documentary should probably be kept to people's selves, but riveting stuff, I'll tell you what. All right, cool cats and kittens, let's get started. Oh, man, I'm going to have to keep saying that. Too much fun. All right, guys, so get open your books. I'm going to start with, Jaden said 3B, I believe. So we'll just go over number 3 on the homework. So go ahead and get that up and open. Takes forever when I'm streaming, so just bear with me here. So page 513, 1 through 3. Michael said, please don't. I will stop watching this stream. Blake, I was confused with the homework because you said something about them being due on Friday, but the classroom said they were due yesterday. Uh-oh. That would be a mistake on my part, Blake, if that's the case. Let me double check. I've been known to make stupid mistakes like that, so it would not surprise me if I did do that. No, it's due Friday, Blake. It says Friday at midnight. So maybe you misread it. I didn't make a mistake. I'm proud of myself. Yeah, it is assigned for Friday, Blake. At least on my screen it is. Maybe you're looking at a different assignment or something. I'm not sure, but yeah, just double check for me. Okay, 513. It looks like it would just be nice, quick, and easy, but turns out these had multiple parts to them. Whoa. This MacBook is not made to stream, people. All right, so guys, page 513, number 3. Let me switch over to my screen here. Oh boy, that's not what I want. I want this. Hopefully you guys are looking in your own books, but this one's about the zoology one. There we go. That should be good enough. So it says, suppose that a red fox population in a restricted habitat follows the function. I'm just going to write the function down. P of t is equal to 16,500 divided by 1 plus 18 e to the negative 0.085 t. Done. Okay. So that's what's given to you, people. All right, and it says graph the function first of all. Okay, I'm not going to graph it. I have a pretty good idea that you guys can graph it. I will put it into Desmos though. So this might help you guys a little bit. So let's go to graphing for Desmos. We're not going to use P of t, right? I'm just going to use y. Desmos doesn't let us use P of t. So I'm going to do y equals 16,500 divide, 16,005. Oh my gosh, guys, I'm a mess today. 16,500 divided by 1 plus 18. Just use the letter e. Raised to the negative 0.085, and then instead of t, right, we're going to use x. Okay. I think that's correct, right? Make sure I got everything good here. Okay, so you guys have this graph, and I'm going to zoom out a little bit. Now, this is the difficult part, and then I think this is probably what Jaden was asking. So if you guys look at this graph, okay, it's going to keep going forever. Okay, and I'm actually going to keep going back. Whoops, there we go. That's what I'm looking for. What did Jaden say? Whoops. You have to zoom out more. Yeah, thank you, Jaden. Sorry about that. There we go. That's what I'm kind of looking for. So this graph looks like it's going to go on forever. Okay, but it doesn't. And the context of the problem actually gave us that information. Because if you guys look at the actual question, the question says that the red fox population is restricted. Whenever we have a habitat that's restricted, it means we can only have so many animals in it. So we got to figure out what the horizontal asymptote is. The definition of the restriction. The horizontal asymptote is telling you, okay, where on this graph, where on this function are we saying there can be no more red foxes? Like at what point? And the graph tells us that. An asymptote prevents a graph from going past it. So a horizontal asymptote is left and right, and it's basically going to say our graph wants to keep going, but it's going to say, nope, you're stuck here. And so if I zoom in at this point here, you can see that that asymptote is at 16,500. Okay? So I don't really need to write down a piece of paper, Jay, and you can see, right, the horizontal asymptote is going to be at y, or P of t is equal to 16,500. And that horizontal asymptote is also the maximum population, because that is our definition of our restriction. That's restricting it. The maximum that population can sustain is 16,500. If you get any more foxes than that, they'll die out because there'll be a fight for food. Whatever this habitat is, it can't sustain more than 16,500. And to find when it hits 16,450, you just want to go back to the graph and just look through the different values. And so it's going to be like somewhere around here, you're going to see. And if you go to 120, bam, you're there. Okay, so that was number 3. That pretty much gives you all the answers for number 3. That does give you all the answers for number 3. Okay, people, any more questions on that? As a reminder, you guys can come in during my office hours. Don't really come in, but you can hop into the chat during my office hours. And then Friday, we'll be going over any questions you guys have. So if you have questions on Friday, we can go over some more. But that gives you all of number 3, so that's useful. How's everyone doing, by the way, today? I didn't really greet us very well. Been an interesting day. I slept like not at all last night. I would say between 3 and 4 hours of sleep. So I'm kind of struggling right now. That's my fault. I don't know why. Just something about this quarantine has really been affecting my sleep. I don't know about you guys, but it's been messing me up a little bit. Gotta get on like a schedule or something. Sierra, you said stress. I'm sorry to hear that, Sierra. Is it school that's stressing you out, or you just got other stuff going on? Aiden, you said you're pretty good. Sleep deprived, yeah, just like me. Not good. I liked it better when I was constantly walking around and moving and wearing myself out, coaching and all that. Now I'm like, got all this energy because I'm not doing anything all day. Sierra, my sisters. Yeah, I mean, regardless of how well you get along with your siblings, if you're in a quarantine with them, they can drive you insane. Jared, I went to sleep at 4 in the morning. Yeah, Jared, I think that's about when I went to sleep. Sarah, yeah. I'm not happy, not proud of it. I didn't plan on it. I was in bed going to sleep way before that, but I don't know. Just something just happened. Couldn't sleep. Oh well, I'm functioning, I'm surviving. I haven't even drank any coffee this morning either. Aiden, for the first time I missed school. Isn't that crazy, Aiden? You're not the only one who thinks like that. I think a lot of people are in this boat right now where they're just like, I never thought I'd say it, but I wish I was at school. You miss your friends, you miss interacting with people. Maybe you even missed your math teachers. Maybe. But yeah, it's hard. You get in these schedules. You're used to everything. You're used to seeing people all the time. You're used to you have your routine, track, sports, whatever you're playing, clubs, all this stuff, and it's like just gets all taken away, and you're just like, hey, sit at your home all day. Mario Kart and Minecraft. That's funny. All the guys play video games. It always makes me wonder what girls do. I know some girls play video games. I know Sarah does, but a lot of them don't. I wonder, I always think to myself, man, I don't know what I would do in my free time without video games sometimes. You can only watch so much Netflix and do so much. Minecraft and Mario Kart. I like Mario Kart. It's a good game. It's a classic. Yeah, but hopefully you guys are mentally doing all right. Make sure you go out and get exercise. If there's one advice I can give. I know you've been hearing it all the time, but it really helps. Go out, just stand in the sun. Just stand outside. Just be outside for a little bit. call your friends, Zoom your friends, FaceTime your friends, whatever. Stay in touch with people. Have you guys ever heard about Jackbox games? You guys ever heard of that? It's like they got a bunch of different games you can play, but it's really nice because you can play them like when you're not in the same place. So obviously, like video games you can play, but like I know for people who aren't into video games, it's like board games basically, but it's over the phone. So you sign into like this place. It's called like Jackbox.tv, and you sign in, and you have all these different games you can play, and some of them are really fun. But it's a good way to stay connected with your friends and family and stuff, and it's very entertaining too. Like Quiplash is my favorite. I don't know if you guys have ever played that, but Blake, okay, yes, Blake, you've played it. Quiplash like cracks me out when I play with my buddies. It's so funny because it just turns into like a bunch of inside jokes, and that make no sense. Michael was to join me in Aiden's village, and I actually don't play Minecraft, Michael. I don't have a PC. I just play Xbox. Minecraft was never my. It looks fun. Like it looks like a lot of fun. People have a lot of fun with it. I'm just not. I'm not into the games, I guess, where you're just kind of creating stuff the whole time. I'm more of like action pack, like shooters, quick action, that kind of stuff. Yeah, it's just like how I grew up. But yeah, I recommend you guys try to get into stuff like that. It's nice with school at least the way it's spread out. Now you don't have to do math every day. You don't have to do science. It's like spread out pretty nicely. So that's good. But I think in your free time, don't just do one thing. Try to expand, work out, play, hang out with family. Learn to cook, read a little bit. I don't know. Just stay busy. You can crossplay. Oh yeah, yeah. I'm not. Minecraft won't be my thing ever. I haven't even played it before, but I know it won't be my cup of tea. I'd be horrible at it. All right. So if you guys ever need something or need help with anything, don't feel free to talk to me. I just hope all you guys are doing good, physically, mentally, and everything. I don't have any updates for you in terms of this whole situation, so I don't know what's going on with school and all that. But obviously we all know that May 1st is the potential day back. So we will see about that, but I don't know. Just from talking to people and just like experts, it doesn't seem like that's a very reasonable. And I don't want to sugarcoat it and like lie to you guys. I don't want to be like, oh yeah, we'll be back. When we there's a chance we won't. So I guess the moral of the story is I don't have the answers. I wish I did, but keep doing what you're doing. And if you're in this live stream right now listening to me, you're taking the right steps. All right, guys, so we're going to get started on Chapter 8 today. So when Mr. Harris gets there in like another 15 minutes, when my book finally gets to that page, we will start talking about what we're doing today. Blake says the rest of the year is going to be canceled. There's a good shot. Don't know. Very, very, very good chance of that. And the way I kind of see things, and I don't recommend it, but I don't like getting my hopes up for things. I don't like to get my hopes let down. You know what I'm saying? So like there's certain stuff in life where I always take the negative route. You guys remember from school when I was always the person that said, "Oh no guys, we'll have school tomorrow. There's not going to be a snow day." And the reason I said it was not necessarily that I always believed it. It was just because you feel much better when you don't get let down, right? When you say there's not going to be a snow day and there's not one, you're like, I called it. I knew this was happening. I was prepared. But if you bank off of it and then you have to go in, then you're like, oh, wow. Then you're really mad. So I'm keeping that approach. I'm going to be the guy that's going to be negative. But in my heart, just understand I'm really hoping we get back. I hope I see you guys at some point. The nice thing is you're not all seniors. We don't have seniors, so at least I get to see you guys next year. I don't have to just say like, oh, you're graduating, we'll see you guys again. That'd be sad. This stupid page, what page is this? Mr. Harris should have been way more prepared and actually gotten a page number. Do you guys have a page number? I'm just here babbling on, trying to find the stupid start of the chapter. Stressing me out. Doesn't help that my book is going like super slow. Yeah, no, I thought I had it. Oh my goodness. 527? What, 509? What are you talking about? Yeah, Blake, exactly. I feel so bad on my calculus students. It's a bummer. I don't get to see, well, I might not get to see him again. I'll see Barron, though, because Barron's going to come back to bully you, Blake. I'm going to see him at the soccer games. Or the swim meets. Okay, guys. This is the page. 528, or 29 was actually the page. So 529 is where I want to start. So guys, go ahead and flip to 529. In the chat, let me know when you're there. Give me a little thumbs up or okay, Mr. Harris, I'm there. Something along those lines. And title your notes, 8.1. Multiplying, dividing, rational expressions. So you guys will see this like fun little scuba diving scene here. Thank you, Jaden. Give you a minute to title your notes. Good looks, Aiden. All right, I'm thinking you guys are good. Thinking you got there by now. Got your notes set up. So like I just titled it 8.1, multiplying, dividing, rational expressions. And new chapter, right guys? So chapter 7, usually we'd have a unit test. We're not going to have a unit test, obviously, because of circumstances. But unit 7 was all about logarithmic functions and all about exponential functions. So let's think about our journey in Algebra 2 so far, guys. We've made it a long way. We talked about linear functions. We talked about quadratic functions. We talked about polynomial functions. We talked about exponential. We talked about logarithmic. We talked about transformations of all of them. Okay, we've gone over transformations of all of these types of functions. We've talked about solving equations with all of these types of functions. We talked about graphing all of these functions. At the end of the day, Algebra 2 is about functions, right? Functions and expressions. That's what it all boils down to. So it seems like we've done a ton this year, and we have done a ton this year. But the overarching theme of algebra is pretty contained. It just exposing you guys to all the different types of functions. Why do we talk about functions? Well, functions are used as a way to express the world around us. Okay, that's why we use functions. That's why we care about functions. It's just a way we can predict certain things that happen around us in our lives. Okay, like a linear function might represent a growth of height. I don't know. Or a population might be represented by exponential. Okay, a quadratic might be representing the flight of a ball in the air or a rocket ship going to the moon. All right, so you have these different functions. Why do we care? Why do we use them? Well, they are a way for us to talk about and to identify and to express the world around us. That's the beauty of algebra and Algebra 2 specifically. Okay, so along this pattern, we're going to keep going, and this unit is going to be about rational functions. Okay, we titled it rational expressions. Expressions and functions are similar. The difference is that expression doesn't need an equal sign. Okay, it doesn't need to be defined as anything. That's not super important, but we're going to start by just talking about expressions, and then we'll get into functions and equations and all that good stuff after that. Okay, so like I like to do, I think it's important we connect math with other subjects. We don't want to just treat math as its own entity. There are certain times where math is just, it just is within itself. But at the end of the day, I want to give purpose to the class, purpose to why we're doing this stuff, and it's because of things like this. So at the very top of the page, we're going to kind of connect this to science here. So it says why up here. It says if a scuba diver goes to depths greater than 33 feet, the rational function t of d equals 1700 divided by d minus 33 gives the maximum time a diver can remain at those depths and still surface at a steady rate with no stops. T of d represents the dive time in minutes, and d represents the depth in feet. So Mr. Harris, why do we care? This is useful to us. This equation is useful to us. Okay, because in real life, it's very valuable for scientists. It's very valuable for people who do diving for a living. Like there are people who literally survive off of diving. Okay, they dive for a lot of different things, and there's an actual term for that. Free diving, I think it's called. I believe it's called free diving. And there's a lot of threats underneath. But if these people have equations, they can tell how long they are exactly able to stay underwater without any issues. So this is valuable to them because before you would have to just guess. Okay, right? These free divers would just have to be guessing. And the issue with that is if you're guessing, you're not sure of it, issues can happen. You can die, you can face a lot of sort of problems, right? So at least this gives you an exact answer to how deep can I go, how fast can I go, all that kind of stuff. Fun fact, right? Something you guys have probably heard of is, I believe I'm not messing this up, it's called the bends. So I don't know all the science you guys have probably learned about before, heard it before, but if you submerge yourself, if you deep dive, if you go really deep underneath the water, and then you try to come up too fast, you get what's called the bends. And it's serious. It's something to do with your blood, and it's something with oxygen in the blood. I don't know the exact science behind it. You guys could look it up. But it's a serious issue. Okay, and it kills people. So this kind of idea is you can't just resurface. You can't just be struggling for breath and then just resurface as quick as possible. You have to resurface at what they say, you can see in the actual example, they say, and still surface at a steady rate with no stops. That's how you avoid the bends. You surface at a steady rate, and you don't stop. So that's this idea of trying to avoid any sort of serious medical issues with diving, because it can be very dangerous to dive. Okay, so this is an example of a rational expression, what you see up there. So kind of going down, I'm going to move down to notes here. So it says a ratio of two polynomial expressions. So I want you guys to copy this definition down. So let me go to my notes here, and you guys can copy what I write on my paper. All right, so rational expression. That is a ratio of two polynomial expressions. I don't know why I spelled expressions like that. That's supposed to be an S. Sorry. So an example, they give you the example of 1700 divided by d minus 33. X squared minus x over 2x cubed. Okay, it's another example. So that's two examples off the top of my head. That's what we call a rational expression. And so this is the key, is this idea of a polynomial. Hopefully we're okay with polynomials. Polynomials are any sort of variable written, so it can include coefficients, constants, all that, but it's variables that don't have fractions in them or don't have negative exponents. So easy examples are quadratics, linear functions, quadratic functions, cubic functions. These are all really good examples of rational expressions, polynomial expressions. And to make it rational, the only difference is you just make a ratio. When we say ratio, it's the same thing as saying division, right? So I'm taking like 1700 as a polynomial function. D minus 33 is also polynomial. So this is a rational expression because it's a ratio of the polynomial functions. Same thing here. X squared minus x is polynomial. 2x cubed is polynomial. That's a ratio because there's a division. That's all it is. So for the rest of this unit, we are going to be working with fractions. We're going to be working with polynomials written in numerators and denominators. That's essentially the gist of what's going on here. Okay, and so this goes in a couple different directions. So I'm going to keep reading on this paragraph here. It says, because variables in algebra often represent real numbers, operations with rational numbers and rational expressions are similar. Just as with reducing fractions, to simplify a rational expression, you divide the numerator and denominator by their GCF. Okay, I don't think we need to necessarily write this down in our notes. So let me zoom in just a little bit. All right, perfect. Zoom me back out. Jerks. There we go. Okay, so you guys can see, right, if we have 8/12, this is a review. If we were to simplify 8/12, we can rewrite that as taking out their GCFs. So they each have a GCF of 4. So you guys can see it's really hard to tell on my screen, but they took out a 4. They rewrote it as 2 times 4 over 3 times 4, and then you can cancel 4s. So you're left with 2/3. This is the exact same idea for rational expressions. And so that's what they show you here. You guys remember with quadratics, how do we rewrite quadratics? We factor, Mr. Harris. Yes, 8 in Bath, very good. We factor. So we factor our quadratics, and then you cross out whatever is in common, right? So x squared minus 4x plus 3 gets factored into x minus 3 times x minus 1. And x squared minus 6x plus 5 gets factored into x minus 5 times x minus 1. Well, guess what? X minus 1 is in the numerator and the denominator. So you can cross out both of them, and then your answer is whatever you're left over with. So in this case, you'd be left over with x minus 3 divided by x minus 5. So this lesson is going to be extremely, extremely useful in reviewing quadratics, factoring quadratics. And we've done that a ton, guys. We've done that a ton. So I know we have a pretty good understanding of that, but this will be even better practice. And specifically, it's going to help you guys practice with shortcuts. And, it's easy for me to say because I've been doing math, for all these years, right? So I've had a lot of practice. So it's easy for me to look at a quadratic and just say, oh, it's just this. Okay, and it's not because I'm any smarter. I just have been doing this long enough. I've had enough practice where it's just like that. I know it. Same idea with you guys. We want to be exposed to enough of these examples where you don't have to make your Xbox, and you don't have to go through that step and try to solve it, right? You can just look at it, think about it for a second, and then you get your factor. That's the goal. It's going to save you time. So that's what I want you guys to really work on when we're doing these problems. Okay. Do you have any questions so far? I know I get in these rambling moods when I'm on stream sometimes, so I want to make sure you guys don't have any questions. Not yet. Okay. All right. Nope. Cool. So let me go to my hover cam here. I'm going to go through their first example here. And I know you can see the work that they do, but I would like to go over it because, first of all, I think it's a good question. And second of all, I can explain everything they're doing. So we want to simplify this. That's all the question asks. So it says 5x times x squared plus 4x plus 3 divided by x minus 6 times x squared minus 9. We want to simplify. If you guys remember when we just simplified quadratics, we go back to whatever chapter that was. I can't remember. Whatever chapter that was, we did a whole thing on quadratic functions. And one of the questions of quadratic functions was to simplify a quadratic function or a quadratic expression. And to do that, we factored. That's how we simplify. Same idea. Okay, we want to simplify this rational expression, but this rational expression is made up of polynomials, first of all, because that's what a rational expression is. But you can see we have different quadratics. So we have this numerator quadratic and this denominator quadratic. So what we want to do is factor those. All right, so I'm going to keep the 5x, and I'm going to keep the x minus 6. Those aren't quadratics. There's nothing for us to do with them yet. I need to look at x squared plus 4x plus 3. Now this is going to be hard, but I'm not in person, so I have to do the best I can. So I have to describe to you guys how I am going to use a shortcut to factor this. Okay, so here's the key. My a term, or my a coefficient, is 1. Whenever a is 1, I can use this shortcut. If it's not 1, then you guys can use your Xbox and go through that. You want to use your Xbox because it's much harder if it's not. But since it is 1, I can use this shortcut. And the shortcut just says, what's a times c? 1 times 3 is 3. Okay, I think you guys can agree with that, right? I need to know what numbers multiply to 3 and add to 4. So add to my b term. What numbers multiply to 3 and add to 4. And this is what you do in your Xbox, right? I'm just doing it in my head instead of writing it out. So 3 times 1 equals 3. 3 plus 1 equals 4. So my two numbers are 3 and 1. Positive 3, so x plus 3, and positive 1, so x plus 1. Don't want to confuse you guys, but if I were to check my work, I can FOIL. So x times x is x squared, 3 times x is 3x, 1 times x is 1x, 3x plus 1x is 4x, and 3 times 1 is 3. So I just FOILed in my head, and I did get back to where I started, so I know I'm correct. You don't have to, you can use your Xbox. I'm not going to take off points at all if you use your Xbox, guys. Go ahead. By all means, if you don't feel comfortable doing your head, it doesn't make sense, write your Xbox. It's not that much more work. It's fine. All right. I think it's useful. I would think it'd be helpful for you guys to try to take these shortcuts and think about it in your heads. Saves you a little bit of time and work. Okay. Now x squared minus 9. This is what we call a difference of squares. Get used to this in math. If all of you guys who are moving on in math are going to see difference of squares all the time. So x squared minus 9, to use a difference of squares, you have to do the square root of x squared, which is x, plus the square root of whatever your second term is, so 9. The square root of 9 is 3. And with difference of squares, whenever you do that, you do x plus that number and then x minus that number. So x plus 3 and x minus 3. Mr. Harris, how do you know it's a difference of squares? Because x squared is a perfect square and 9 is a perfect square. And a difference means there's a minus sign. So it's x squared minus 9. Okay, so I know I really discussed that in a lot of detail. But I just did that on purpose just because I wanted you to understand where I'm going through. Because now, from these problems from here on out, I'm going to go a little bit quicker. All right, so when I'm simplifying, pretty simple from here. All I got to do is look at the top and the bottom. What do they have in common? Everything is being multiplied. That is the key. And that's the number one mistake. One of the number one mistakes in general I see in math, honestly. is people think that they can cross out terms even if there's addition. The only reason I can cross out these terms is because everything's being multiplied together. So because everything is now being multiplied together, x plus 3 is considered as one term. So that means I have that in the numerator and the denominator. So I just cross those out. Cross out x plus 3 in the numerator and denominator. And I'm going to look at every other term. Do I have a 5x in the denominator? No. Do I have an x plus 1 in the denominator? No. So my final answer then is going to be 5x divided by x minus 6 times x minus 3. That's my simplified rational expression. Okay, so the next part of this question, let me go back to this screen, is you guys can see it says under what condition is this expression undefined? Well, think back, when is an expression undefined? Okay, an expression is undefined whenever the denominator is equal to 0. So if you guys look back at the original equation, the denominator is 0 when x is 6, because if I plug in 6 up here, that gives me 0. When x is negative 3, because when I plug in negative 3, that'll give me 0. And when x is positive 3, because again, if I plug in 3 for x here, it gives me 0. So the conditions the expression is undefined is at 3 different spots, x equals 6, negative 3, or 3. So whenever you guys see the word undefined, you're just looking for when the denominator could be equal to 0. What values of x make the denominator equal to 0? That's all part B was asking. Jared, you said what happens to the x plus 1? There wasn't... Oh, good call, Jared. X plus 1 should still be in there. I apologize. Good catch. Yeah, guys, I, for whatever reason, just ignored it. That x plus 1 is in our answer. So it should be 5x times x plus 1 over x minus 6, x minus 3. Thank you, Jared. I would give you a piece of candy, but I can't really do that over the computer. So just imagine I was like, hey, Jared, good looks, and I threw you something. So. All right, guys. I'm going to flip to the next page here. We have 15 minutes left, and I do want to get through all the notes I need to get through for this. So I'm going to go a little bit quicker here. So example 4. Wait, hold on. Let me double check. Am I on the right page? Oh, here we go. I was going to say, we shouldn't be on example 4. Okay. No, please don't. All right, we're good. All right, so that was the first type of question with division, just simplifying. So you simplify the numerator and you simplify the denominator. Standardized test example 2, you can see they do the same thing. So let me go actually to my screen here. Guess you don't need to see my notebook. Okay, so if we're looking at this example here, this is the exact same type of problem. It's the only difference is the question's asking when is it undefined. So we would factor the denominator, and we would just look to see all the values of x that would make it undefined. That's just very similar to the problem before us, so I don't feel the need to go through that. Okay, the next big example I want to talk about is if you factor out a -1 to help simplify an expression. So let's look at example 3. So I'm going to write down example 3. You guys should do the same in your notebooks. Okay, and let me switch on over to my notebook. So we have 4w squared minus 3wy times w plus y over 3y minus 4w times 4w plus y. A lot of words there. And we're just simplifying this. So we want to simplify. So I want you guys to look at this and treat it the same exact way. Okay, so same exact way as example 1. So I'm going to look at the numerator and denominator separately and simplify them both. So the numerator, first things first, what do you think we should do? Okay, and the best thing to do is to factor. We always want to factor out a GCF whenever possible. So I'm looking at this first set of parentheses. What do they have in common? Well, 4 and 3 have nothing in common, so ignore that. W squared and W have a W in common, and then only one of them has a Y. So if I factor out a W, I'm going to get 4W minus 3Y. Okay, and I still have W plus Y divided by. I'm going to rewrite this just so it'll be a little bit easier for you guys to see. Instead of 3y minus 4w, I'm going to write minus 4w plus 3y. And then times 5w plus y. Okay, so the only thing I did in these steps, going from here to here, is I factored out a w and just rewrote one term. And I did that on purpose, and you'll see why. Okay, my goal is to simplify. I want us to cancel terms out, essentially. I want to make this look easier, more presentable, something I'm not annoyed by. Okay, and I can cancel something out, and it's just not really obvious right now. If you look at these two parentheses here, you can see they're very similar, right? There's a 4w and there's a 3y. So you're in your head should be thinking, oh, I want to cancel that. I want to. It's hurting me that I can't. But you can't, and here's how you do it. So I'm going to keep the numerator, that's fine. We'll keep that the same. So everything in the numerator, I'm going to keep the same. Now the denominator, I want to change this denominator. So instead of negative 4w plus 3y, I have positive 4w minus 3y, because I want to cancel out that term. So you should be thinking, you probably already looked in the book, you probably already have the answer. You have to factor out a negative 1. So factoring out a negative 1 from negative 4w plus 3y. Well, negative 4w divided by negative 1 is positive 4w. Positive 3y divided by negative 1 is negative 3y. And look at what we have here, guys. We have a 4w minus 3y. I don't know why I got really southern there. We got a 4w minus 3y in the numerator and the denominator. Okay, so if we have matching terms in the numerator and the denominator, everything is being multiplied. What can we do? We can cancel them. I don't like to be obnoxious with my canceling. Just really get rid of it. Act like it was never there. And what I'm left over with is w times w plus y divided by negative 1 times 5w plus y. And that's my final answer. One thing I want you guys to be careful of, and I never understood, and because mathematically it doesn't make a difference, but in general with math, you always want to take the numerator or the negative and just put in the numerator. So instead of writing in the denominator, you want to put in the numerator. So instead, I'm going to actually rewrite this as negative w times w. Whoa, I'm out of control. Let me do that again. Negative w times w plus y divided by 5w plus y. Okay, that's generally, and that's how the book will express it, so figure I'll stay consistent. Any questions, guys? We got about 7 minutes. By the way, now that there's a little lull, go ahead and smash that like. It would be remiss of me to not mention it. So, yeah, just go ahead and smash it, destroy it if you can. Subscribe, turn that notification bell. I don't know what any of it does, but it does make me feel good when I get some likes on my posts. Makes me feel like I'm being productive and I'm actually improving my abilities. So I'd highly appreciate that. Okay, I don't see anything in the chat, either because everyone just is completely ignoring me or because you don't have questions. So I'm going to assume it's the latter. Probably a bad assumption to make, but I'm going to assume it's the latter. And that you guys you're good. You're feeling good. All right, so what I want you guys to do, there's a lot of reading and stuff. I do want to get through this because I got sidetracked a little bit. So in your homework, you guys are going to have an Alex assignment. It should already be posted. But on that Alex assignment, it's just going to be the stuff I'm lecturing today. And I think there is questions on multiplying rational expressions. So I'm going to go through this pretty quickly. I know we don't have too much time, and I apologize for that. Because I'm not positive if I put it on the homework or not. I can't remember. My bad. Thank you, Michael. I know that's not true. As Michael would say, oh, Mr. Harris is my favorite class. This is the best class I've ever taken. Unbelievable. That's what Michael would tell me every day. I missed that, I'm going to be honest. Okay, so I do want to go over example 4 really quickly before the end of class, guys. 4A. There's a ton of stuff. When you're doing your homework, again, I can't remember if I put this on there or not. But if I did and you guys get multiplication, so that's what we're doing is we're going to multiply rational expressions. If you guys get a question like that and you're like, Mr. Harris never went over this, what the heck's going on? The book's got some more details. I don't think it's necessary for you guys to write it down. But so here's the question. You guys can see it's question A. And I'm going to actually go over to my HoverCam because I want you to see my work for it. Whoops, let me do this. Okay, so the book does it a little bit differently, and I think the book is more confusing than it needs to be. So whenever you guys multiply a fraction, I'm going to just do this off the side, you don't need to write this. Okay, 2/7 times 3/8, two fractions being multiplied. How do you do it? You multiply the numerator together, 2 times 3 is 6. You multiply the denominator together, 8 times 7 is 56. That's it. All right, that's how you would simplify that multiplication, right? Okay, same exact idea for multiplying rational expressions. These are both rational expressions. If I'm multiplying together, you're going to first multiply the numerators together. So 6 times 15 is 90. C times C is C squared. And D squared. So I get 90 C squared D squared. Okay, 5 times 8 is 40. D is just D, and A is just A. So it's going to be 40 AD. So what the book does is they kind of factor them separately. So the book will say, okay, what does 6C and 15C D squared have in common? And they'll do it right in one step. I don't know. I don't really like it, to be honest. In my opinion, I think this is easier. You don't have to do it this way. You guys can look in the book and see their explanation, see how they did it. Fine, go ahead. I really am not super concerned how you do it. Obviously, my bigger concern is that you're understanding what's going on. So at the end of the day, the point is we need to get to a situation where we can start simplifying. And when I say simplify, I mean I can start crossing things out, right? So let's start with the 90 divided by 40. Easiest way to look at this is they both have 10 in common. So I can essentially just cross out the zeros. So 90 divided by 40 simplifies to 9 divided by 4. Okay, C, the next term, there is only in the numerator. So you can't cross anything out with C because it doesn't exist in the denominator. So I just have C squared remains the same. Same thing with A. A is only in the denominator. So A remains the same in the denominator as well. Now D is different because D, I have D squared up here and D to the first down here. So if I have one D in the denominator, two D's in the numerator, I can cross one of them out. So I'm essentially getting rid of that D, and I'm going to turn this into a 1. I took 1 away from the numerator. So that means that my numerator, I have a D to the first. So your final answer then simplifies to 9C squared D divided by 4A. So that's how I like to solve these problems. Like I said, the book does it a little bit differently. Whatever works for you guys works for you guys. So maybe give me some feedback. I mean, I'll see your Alex assignment. I guess that won't really help me because I won't see your work. But I know at some point down the line I'll be able to see how you guys are doing with this and what your method is. So, okay, and that's the end of the class today. I'll stick around for another minute. I know I went through a little quick at the end. If you guys have any questions, I'm more than happy to help out right now. If not, I'm going to take off, eat some lunch. I will be back on from 1 to 2. You have an Alex assignment. Every assignment's due Friday. If you have procrastinated and are missing a lot of assignments, I will accept them by Friday, but I need them by Friday. The quarter ends Friday. I'm not going to, unless there's an exception, I'm not going to take any work after that. So I need you guys to get on that now. Start doing your work. I appreciate some of you have been and emailing me the work or submitting it to Google Classroom. You guys are awesome. Keep that up. Get your grades right. I really appreciate the people who were in the stream, 12 of you or whatever it was. You guys are great. I hope you're all doing well. I'll be here from 1 to 2 for my office hours. I will also be on Friday. So 11 to 12 guys Friday. If you have any questions on anything throughout the week, doesn't matter if it's from notes, doesn't matter if it's from a homework, an assignment, whatever. Any questions you guys have, hop in on Friday, ask me. All right, you're welcome, Sierra. I appreciate you guys. Have a great rest of your day, and I will talk to you. Feel free to email me if you have any questions. Peace out.